Hey there, there's this particularly underused feature of modern-day frameworks that I've chosen to name the implicit props pattern. It doesn't really have a name just yet, but it's a pattern that comes about due to the introduction of what many frameworks call context. In essence, it's the ability to attach state to a component tree. Some frameworks talk about it as a way to avoid prop drilling, but it really is a marvelous idea that brings about the ability to use our frameworks in ways they perhaps didn't intend, but is still wonderfully useful. Note that with a context system, we're talking about attaching data to the component tree, not the DOM itself. This is a framework concept, not a web one, although we can simulate context in a vanilla web experience, as seen over here. As we can see here, although these components don't seem to directly communicate, this child node can access state that the parent component has provided to it, simply by existing as its descendant. This other child node does not have this ability, as it isn't a child of that specific parent component. Using this context system, we can have components that affect each other's presentation without us intervening directly, and making sure the states match up. Here, our save phrase component can retrieve the context object and use the color property to color a particular part of its view. This is the implicit props pattern, pardon the alliteration. I'm differentiating this from the term context, as what I'm describing is the consumer experience in terms of component composition, rather than the underlying mechanism for how it's achieved. But why do I think it's so useful? Well, I'm about to show you two particular components that greatly benefit from this pattern. These components will serve as examples for two separate ways that one might take advantage of this. And let's zoom out, and behold. There we go. I've decided to use Astro for this video in order to write the same two components in 4 different frameworks: Vue, Svelte, React, and Solid. I think these frameworks have a lot in common, but enough things separating them that the code tends to differ in ways worth talking about. So what did I make here? Each framework box has an audio player and a tab component. For the audio, we use the Web Audio API to emit a sine wave at a certain frequency. We can use this range slider to alter this frequency in real time. I apologize for the sound there. This tab component seems as equally simple. We have 2 tabs that allow us to alternate between 2 views, tab 1 and tab 2. What's interesting here isn't the resulting view, but instead how we created them. Our user-facing API for the audio player looks like this. This mimics the real Web Audio API, in which we connect oscillators to effects to gain nodes to our audio context. We're doing the same work, but in a seemingly much more declarative way, using XML. Connections are shown via the XML itself. We know oscillators are connected to gain nodes because they're nested inside of them. By virtue of their positioning, or context, this works and happens all because of information behind the scenes. We can also alter values like frequency or volume in a way made much easier due to the framework we're using. We're taking advantage of the same constructs made available to us for any other element and using them to create a declarative API over an otherwise imperative interface. And we'll go over how imperative that interface is in a little bit. The tab component API is also pretty simplistic. We simply nest our HTML inside a tab component, or tab contents component, which is itself inside a tab container. The use of the implicit props pattern doesn't seem immediately necessary or even apparent at all. However, if you were to make this component without the use of some context API, we would need to add a labels prop onto tab container. We would need to keep the names of our labels in sync with our labels array at all times. This gets annoying when your individual tabs get much larger and more complex, or when tabs themselves are loaded in dynamically, because the labels for each of our tab contents need to be kept in line with the tab containers labels. So let's open up our project and take a look at some code. We're going to start off with our tab component in React. And as you can see with our Astro project, this is how the directory sort of looks. Now, for our tab components, the index file isn't going to be too interesting, so I'm not going to generally go over those. In React, a context is created with react.createContext, or just create context if you import it normally, like I did not, in which we supply the shape of our context, data, in return for a wrapper component that should encapsulate children of some sort. We'll get over the specifics later. Our tabs container component over here does all the heavy lifting. We initialize a piece of state to keep our mapping of labels to data, and another piece of state to keep track of the currently selected tab, called current tab. I would normally prefer the map constructor over an object for this use case, but frameworks like React and others use shallow equality when diffing two states, and creating a new object from an old one is easier with object literals over a map. Now, I'd like to stop real quick to clarify that although a lot of this might seem complicated, this is the most difficult part. We're going to see a lot of repetition when it comes to seeing how the other frameworks do this. Well, back to the code. Next, we create our provider data, the object we're going to pass to our context. We're going to memoify for performance in this current case. Later on, we're going to see a use case for a use memo that isn't necessarily performance-based, but we're going to touch on that in the future. Inside of our use memo, with our add tabs method, we expose a set tab, which is just called add tab, and that just takes the current label and data and sets our local component. If it's the first one, meaning if the object keys are empty, we set that component as our current tab. Remove tab, pretty simple. We use destructuring and rest over here just so that we can easily, spread, just so that we can easily remove and add things with object literals. That could have been done in a more imperative way, but I thought this might be simpler to read. The object itself isn't too complicated, and so we'll just continue on. Later on in the code, we create the labels and a way to change the current tab. We also display the current tab ourselves, and then wrap the children in a context provider. Right over here. Our children will be comprised of tab content components. These simply grab the context and add their own children as a tab, like this. And then on unmount, we return a function which removes the tab. And this is how the on-unmount works in React. We have a use effect, and then the return value is a function. That function gets called when we unmount, where we just remove ourselves. And this is generally how context works in React. Nothing too complicated, but we're going to see this sort of pattern in the future, especially in a moment when we discuss Solid. Solid syntax looks surprisingly like React, but its rendering model is very different. This won't matter much at the moment, but when we get up to the audio component later on. Creating our context and initializing our state isn't much different from before. Over here we have create context. There are some subtle name changes we're going to see later on. We don't need to memoify our provider data because of the rendering model of Solid.js. Solid.js does not rerun our function each time something changes, like how React does, so we won't be redeclaring or recreating this function a lot, just on the first initial creation of our component. Our objects look very similar to the previous one, the add tab and remove tab. We recognize the set tabs function as beforehand. The difference of here with add tab is we're going to batch two different reactive changes, whereas React, this might have been done automatically for us in some sense. We're going to set the current tab, and we're going to set all the tabs, right? Same thing as last time. We check if it's empty. You might notice that we call functions instead of just access values. That's again because of how Solid.js's rendering model works. This will get the current value of tabs when we call it, and won't be a stale value from the last time. With React, in order to avoid stale values, we have this whole different rendering model. But over here, it's just a function. It's a getter in some sense. For our JSX, we use the for component instead of a map for performance reasons specific to Solid.js. We add a class list instead of a class name, which makes it slightly simpler. With onClick, instead of returning a function that is a closure, we actually return the onClick function itself, and then the provided data. Just makes things a little bit easier, a little bit more performant, a little bit more of an ease of use. The provider works same as before. Over here, same as before as well, where we return please add some tabs if we don't have a current tab at all. But again, we instead call our functions instead of using the literal values. Our tab content is the same as beforehand. We have use context, we have their add tab, and we have an on cleanup function. We don't need to use a use effect for our add tab as anything over here again, because our function is not rerun. We don't need to worry about the on mount specific thing. All right, just add that right over there, and we're fine. Let's move on to Svelte. And as we move on to Svelte, we leave the JSX world, but we stay close to Solid's reactivity model. In Svelte, we need a separate file per component. Let's go to the tab container. You'll notice we don't have to call create context, but instead we have set context. We don't wrap our children in anything either. We simply supply a key, which we declare over here, which we also export, so that children who want to use our data can import that. We could have used anything for a key. A symbol would have worked just as well. However, Svelte docs use an object for the key, which is essentially the same thing as a symbol for our purposes. In Svelte, local variables are automatically reactive, so we don't have to wrap tabs in anything. You'll notice I'm using an array of labels as opposed to an object like last time. We had an object of labeled children mappings. This is because we can't actually pass children around as variables in Svelte. Instead, we use the slot component, where it serves as a placeholder for the element's children. This means we will not be able to take care of presentation like we did last time inside of React and Solid. Our tabs themselves will have to be in charge of that. Because of this, our context will have an additional item, which is the active tab, which before we called current tab, which is a reactive variable on our context. This will let our child components watch for when the active tab variable changes so that they can know when to render or not. In Svelte, reactive variables are their own getter and setter. Before in Solid.js, we had a getter and setter variable exposed separately, but over here we just serve one specific variable, which we wrap in a writable. Local variables are reactive by themselves, but if we want to share variables across files, we're going to have to make them writable like this, which creates a store or a signal, whatever sort of terminology you'd like to use. As for our tab itself, same as beforehand, we use getContext with that specific key that we imported as well. We get our active tab, and we watch for the variable using the $sign, which makes it automatically reactive. If active tab equals our current label, then render our children itself, our own slot. Now let's move on to Vue. Over here. Same as beforehand, like this. Now, with Vue, we follow similar folder constraints to Svelte. Just close this over here. And we'll also find ourselves under similar constraints in terms of the children variable. Here we see slot again. I'm using Vue 3 along with the composition API because it's honestly just less code and a lot more similar to Svelte, and I thought the distinctions might be interesting. Our tabs and active tab variables are made using ref. Over here we don't have the ability to have local variables be automatically reactive, at least not in the current version of Vue 3. Reactive variables are made using ref instead of writable like last time, and ref variables expose a .value property, which itself has a getter and setter on it. It's really a class. For arrays, the value is actually a proxy, and so I used filter over here. I really didn't have to. I could have used .splice. I just don't like how .splice looks. We can use .push over here and get that automatic reactivity, because again, arrays specifically are proxies, or at least objects are, and arrays we know to watch for the .push operation. We export our active tab and tabs variables so that it can be used inside of the component HTML code. We have our span, we have v-4, we have the colon keys, which is, having keys equal to the current tab. We have an object for our class, which is similar to Solid.js's conventions. And we have @click. We can have the entire function inlined, which is, kind of useful and convenient. We expose tab over there. Like last time, let's go to our tab content component, which is again very similar to our Svelte one. We have v-if instead of wrapping it in a hashtag if block. We have active tab equals label. Over here, we don't have to have a $sign over here. It's automatically reactive, same as last time. We add it to the top level, and we have an unmounted function. That's what Vue calls it. Every framework will have a slightly different name for what they call certain things. At the end of the day, it's the same idea. I kind of skipped over the fact that we called it inject and provide. Again, Slightly different names, the same idea. We expose a key, which we're using a symbol this time for, but it's just called provide and inject instead of set context and get context, for whatever reason. Now let's go to the audio, but let's go backwards this time. And we'll start with Vue. This time I am going to go over the index files because I do think they actually have something interesting to give us. Over here within our template, we have a button which we say stop or play. For is playing equals, not is playing, which is our toggle over here. And so it toggles itself, its own text content, but it also toggles if this audio context node exists or not. This node, if removed, stops itself from playing. And if it exists, it will automatically play. And so we can treat this HTML code as a sort of start-stop button by just removing it from the page. Now, despite it being shown as HTML, it doesn't actually render anything to the page. Instead, it's sort of all functions, which we're using as HTML. We have an isPlaying and frequency ref, which we again expose in the same way beforehand, but we bind frequency to our reactive variable. And input itself modifies what frequency is. We have min 100, max 1000, and so there's very little code here, but we have a very powerful sort of system where we can automatically change frequency as it's automatically bound to the input range and automatically bound to the oscillator node, just like that. And so we can just bring back up our component again, just to show you. We can play audio. Again, with very little setup, we automatically have the ability to change the frequency and warble about a bit. We can also bind to the volume if we'd like. I did not in this case, but maybe you also want to change the type of oscillation we have, from sine to a saw wave to a square wave, or whatever you'd like. You can chain a bunch of them, create new ones, and so on. But nothing too fancy, at least in our script section. Let's finally dive into one of the more complicated parts, the audio context. And over here, not too much going on. We create a new audio context. When we're unmounted, we close ourselves. Same idea as last time, where we automatically remove ourselves from the picture once the HTML is removed. We have the same idea with set context, but we call ourselves provide. We have a key, which we also export. We provide ourselves, and then what we call the parent node. Now, I'm not going to dive too much into the Web Audio API, just going to briefly discuss the parts that apply to us. The parent node idea is with every single audio node, we connect one onto the other. And so the audio context.destination refers to your headphones, or where we're playing it. And audio context itself refers to the context of how our audio is played and consumed. In this case, this means in real time. This inherits from the base audio context. There's also called the offline audio context, where we can render audio as fast as possible, so we can put it into a buffer. Not super important. Not going to discuss those, maybe for a future video. But the idea is we're creating a parent audio context for our audio to sit inside. Our gain node retrieves that data with inject, same thing like get context. We get our audio context in the parent node. In this case, it's just audio context.destination, which we could have gotten anyway, but in the future, it won't be the same. You'll see in a second. We create a gain node using the audio context. We connect it to the parent node, and then we set its value based on the props. Here's something interesting. The onUpdated. onUpdated runs any single time we get new props. We can declare it over here like a regular function inside of our setup. If we're using a different Vue API, the previous one, I think it's called the Options API, we'd have a much larger component, but we're not. And so how we do this is we get the end time when we want to ramp to, and then we ramp to that value. Now, you'll note here that I'm not just setting the .value property like this, although I could. The reason why is because that change would be very jarring. But instead what I'm doing is giving a 0.1 second delay, or 100 milliseconds delay, between our current value and the next value. So we have this sort of smooth warble effect, and I'm going to show you it one more time just because I think it's a lot of fun. And it just sounds like a lot of fun to play around with, and is a much better user experience. Like if we had volume, imagine it changed that drastically each time. And in fact, when we play the audio, we can hear a bit of a snap. I could have also changed that by having a linear ramp, and just decided not to. We also, again, set the parent node to ourselves, but pass the same audio context along. For the oscillator, we get the audio context and the parent node. We create an oscillator using the audio context, set its type to sine, we set its frequency, We connect it to the parent node like we did last time. That's how nodes work in general. And then we start ourselves automatically. Now we're starting ourselves because we've set the system such that if the audio context exists, then we're starting the audio. The audio is played automatically if we're at all rendered on the page. And so if we're here, start ourselves. We create an onUpdated over here where the oscillator type is a sine, or whatever we supply to us with props.type. We also have props.frequency to update our current frequency, and we ramp to that value automatically. We don't really have an easy way of differentiating whether the new props have the sign has changed, the type has changed, or the frequency has changed. We can check for that manually. I decided not to in this example particularly. And again, we set the parent node to the oscillator. And each time, you'll notice we have a very, very little bit of HTML, a template with a slot, because we're not actually rendering any real HTML. And I think Vue is going to throw some errors in the console because it's saying, hey, you're not really rendering anything, yet you have slots. And we're just having these in case we want to nest something inside of the oscillator itself. We want to connect something to the oscillator, maybe some sort of visualizer node to create some other frequency band spectrum analyzer thing. And again, this is all composed together like this. So I made it a self-closing component. We could have had something else inside of it. And now let's jump to Svelte. Let's go to our audio. We have our index file. Again, things are automatically reactive if they are local. We have isPlaying equals false, frequency equals 300 as our default values. The same sort of HTML we saw beforehand. Our onClick function looks like this. It's on::click in Svelte. We're binding the input's value to the frequency, and again, because they're locally reactive, we don't have to do much. The frequency is automatically set on the oscillator. The audio context looks very much like Vue. Audio context is created over here. We're setting our context to this local key with audio context and parent node. When we destroy or unmount, in Svelte it's called onDestroy for whatever reason, we close the audio context. The gain node is similar to the Vue one again. We do export let, that's how we do props inside of Svelte. We get the context, audio context and parent node. We create a gain node connected to the parent. Before update is sort of, the onUpdated hook. We have also after update in case we want to care about that. We don't really care about that in this case, so before update is fine. We ramp to that frequency value, and then we set the context of our component, again, to audio context in the parent node. Now, just to go back and forth why we're doing this for the set context, the idea is we want our tree over here to be distinct so that when we get the parent node inside of oscillator, it's the gain node. And in gain node, when we get the parent, it's the audio context. So we're creating a new context each time just so that when you get the context with the same key, you only ever really go one component up. But what we could do, if we wanted to, for whatever reason, and I don't know why, is make a div and another div and keep doing this. And the parent node would still be the gain node because we're using the same context tree. So we don't really care about these divs over here. So we'd still be going up one more audio context node, I guess. Let's just Control-Z those away. And for the oscillator, again, nothing too different as beforehand. The same way we created an oscillator as beforehand, we expose frequency and type. These are our two props. Before update, we sort of change these values. We ramp that one over the duration of I apparently did 200 milliseconds here. I just, oops, sorry to realize that. And then the parent node, same idea over there. Nothing too complicated. Now let's go back to Solid. Now, because we're dealing with JSX, we can actually have everything in one file again. So we have this massive audio context file. Let's first go over to the index. We see isPlaying and set isPlaying, frequency is set frequency with create signal. These again are our local reactive values, variables. I just jumbled that. Change frequency, we have set frequency equals the number of e.currentTarget.value. This is basically the two-way binding system we talked about beforehand. Solid.js does not have native two-way binding. Who'd have thunk it? And so we have value equals frequency, and on input, we change the frequency. Same as beforehand, nothing too complicated, just this time it's a bit more explicit. We have a show component. This is sort of our hashtag if in Svelte and v-if in Vue. This is just how we, remove and add components. And when equals isPlaying. Our audio context. Frequency is sort of bound to this frequency value over here. Not two-way bound, just, it reacts when we change our value. Our audio context file looks like this. We create context, same way we did in React with create context. Now, note in our create context, we sort of create the shape of our values. We saw this beforehand with React's context, but SolidJS works the same way. We sort of create the shape of our context object before we actually provide its values. Over here, it's just going to be null. We can do undefined as well. It doesn't really matter. We can also have numbers. Again, just the shape should be there. But for typing purposes, maybe you want to do null or type it as audio context. For provider data, again, we don't need to memify it like we do in React. We have an onCleanup function where we close ourselves. We create a provider, which we wrap our children in. Our gain node, same as last time. Gain node, pretty simple. We have a use context. We create effect. So create effect is sort of our onUpdated thing. We don't really have a component-specific onUpdated hook. And that's because we don't need it, actually. When we change a prop, we cause a reactive effect. Create effect automatically watches our reactive values and runs this function anytime they change. In this case, it's going to be props.volume. We can't actually destructure it due to how SolidJS's reactivity model works. If we destructure props to get a volume itself, so if we just did something like, const volume equals props, and then we did this, this actually would not at all be reactive. This would be a big no-no, so we have to keep it as props.volume. It works based on a proxy, and that's sort of how it knows to make this a getter. So before we had a function, a literal function which we called. Over here now it's a getter. Sort of a bit hidden in some sense. And this effect runs every single time this changes, so we don't have to have a specific onUpdated function. Create effect by itself as a reactive primitive is already enough. Provider data, again, don't need to memify it, add it to our value. Oscillator node, same as last time. Use context, we get the audio context in the parent node. Here's something interesting. In SolidJS, we can have a separate effect for different reactive variables because this is how reactive primitives work. We can watch the types change and we can watch the frequency change. Beforehand, we had both of these in the same function. Now, we can have a separate effect for if different props change. So if you change the type prop, something different will happen than if you change the frequency prop. We don't have to have an if statement. It's a separate function altogether. And of course, the provider data, which we wrap again. Right? Nothing too crazy complicated over here, but that's how SolidJS might handle it. Now onto React, and I changed my intonation in this way because we're going to get into a bit of a doozy here. And I'm going to use this as a sort of opportunity to educate you guys on how React works, because apparently people don't have the correct model for it, unfortunately. Our index file, nothing too complicated here. Very similar to Solid. Same as usual. We have frequency and set frequency. We have a change frequency function. The same way we typed it beforehand, just using a little bit of a TypeScript over here to make my editor not yell at me. We have a show audio and. This is how we, conditionally render components in React. We, change frequency. We don't have to call a function over here. It's a literal value. Our function will get rerun each time set frequency is changed so that this isn't a stale value. Audio context. So I've separated it into separate files, even though I don't have to. As we talked about beforehand, React and SolidJS, we can have all of our components in the same file. Although with React, we're going to see why each component is so much larger than it was in SolidJS. And because of that, I didn't think it was more legible if they were all in the same file. So they've been separated out. Our audio context over here, we memoify our audio context itself. Okay, so beforehand we talked about memoization as a concept used for performance. I'm not using it exactly in that way over here. We're using it to semantically memoify something. This is something that React says we explicitly should not do in the React documentation. I've talked to some people. It's fine for our use case, particularly. You could have used useRef or useState for this. Those are just a bit, more in terms of what you're writing. So I decided to use useMemo. This is just a performance thing with provider data. But I'm going to talk a second about why you're going to see useMemo a lot in the coming components. And it's for a very good reason. React, as its rendering model, if React gets the inkling, the idea that any part of your component needs to re-render because maybe something changed, it will run your entire function again and again and again whenever it has this idea. So audio context node as a function will be rerun and will use its new output if it thinks something has changed. Or when React wants to see if it wants to use its new output, so it'll rerun the function to see if the DOMs or the virtual DOMs are different. It will do a diffing process. It will take the new DOM and the old DOM, or the new values and the old values, and see have they changed. Are they literally equal or literally not equal? What is the strict equality comparison? We need to do use memo over here for that particular reason. If we don't use memo, and every single time React has the idea that maybe something's changed. Now React doesn't know this yet. Maybe nothing changed. But React has to check because it doesn't know for sure. It will rerun our function. When it does that, if we do not have use memo on, when it reruns our function, our audio context will be different. And because it's different, all of our nodes on the bottom won't get the new node. And so they will continue to play while we don't have control over our children anymore. So when we unmount, we do audio context.close, it'll be a separate component that is unmounting. The audio context will be unmounting for a different component. And this is going to be even worse later on when we get to our gain nodes and oscillator nodes, and I'll show you that in a minute. We're memifying our provider data again because of how context works. Again, this is a performance reason. The reason why I'm doing it is because if we were not to memify this, then every single time we run again and again and again, we create a new object. And because objects are not equal to each other, if they are new, this should return false over here. A new object would trigger this new context value to update the children who rely on it. You're also going to see use unmounted over here. That's a little basic hook I made to make the unmounted process easier. In reality, you'd create a use effect that returns an unmounted function, but because our .close is a promise, TypeScript is going to yell at us, so we have to void that, and so I just decided to make it a little bit simpler. We also have to have an empty array over here, and you're going to see empty arrays for all of our memo functions. This is also very important because the array describes our dependencies, meaning under what context should we invalidate this memo. And we want that answer to be never. Only invalidate the memo when it's first created, meaning the only time this function should be run is when it's first created, and that's it. If we didn't have an empty array over here, what that means to say is always invalidate it and expected 2 arguments. That'd be a bad idea. We shouldn't really have nothing here. We should have instead an empty array. Okay, now let's go on to our gain node. Our gain node, a bit longer this time. Okay, use memo. Again, we need to memify this process again, and I returned the node from this memoization because, again, if we ran this function each time we thought something might have changed, our node would be different each time. So we might be creating like 50 new gain nodes. And imagine when React thinks something might have changed, you instantly get barraged with 80 zillion oscillator nodes, and all of a sudden your headphones break, because of course they do. That's an incredible amount of audio to play at the same time. We're memifying our provider data, again, more for performance reasons. We have a use effect. This hook will run when things change. Our dependency is on volume, because use effect with an empty array will only run on mounted, but with a specific volume in its dependency array will run every single time the volume props has changed, which, makes sense. Use unmounted, we're going to be reusing that same hook that I created earlier because I think it's a bit of a convenience. Gain node.disconnect, we're disconnecting our gain node. We don't really have to do this. I actually didn't do this with our other frameworks, but I'm just kind of using it again and again just because if our child got removed in a different scenario, then it might actually matter. I didn't have a conditionally render the gain node or oscillator node. So for a specific purpose, it's not going to really matter to have an unmounted hook for our gain nodes, but in practice, if we're making a library, we probably should. Our oscillator node, again, we need to memify, because if we don't, we're going to be creating 50,000 oscillator nodes before we can shut them down, and our headphones will blow out. Use effect. This is a bit interesting. Now, the fact that Solid.js and React work like this, just because they both use JSX, complete coincidence, just how the rendering models happen to work, we can actually have a dependency array on use effect and make it different from the other use effect. So we can have 2 specific use effects with different dependencies to separate out what happens when certain props change. How about that? So in React, we actually can have a use effect specifically for the type and specifically for the frequency. That I think is kind of cool. Again, a use unmounted hook. And we return the audio context provider. And again, as I mentioned beforehand, use memo might not be the best thing to do because React says in the future, use memo might be invalidated for whatever reason. What someone tells me, it's actually, the purpose is potentially for virtualization, like for virtual lists. If you don't know what that is, you can Google it. It's not really going to affect us in our specific case, and if it does, it'd be a breaking change anyway, and so we shouldn't update React version. We'll be fine for most purposes. And that is the implicit prompts pattern. It's been a bit of a long video. I understand that. I tended to ramble a little bit over there. I had a more specific controlled script, which I did not follow because I thought it would be faster if I actually looked at my screen and showed the code and how they worked. I'm going to go over to the page again over here just to show you that they all work. I did not mislead you in showing you improper components. These all work just fine. Some might work a bit faster than others. I'm loading all 4 frameworks on the same page. Thank you, Astro, I guess. But that's why the page itself might be a bit slower. There will be a repository for this code, so you can dig into these samples specifically in the description and perhaps look at how the implicit prompts pattern can benefit you. We do see the implicit prompts pattern a lot in particular areas. I wish I could actually show you specific samples, but we have React 3 Fiber and we have Svelte Cubed, which are really having frameworks declaratively show a 3JS 3D rendering, which I think is really, really cool, to declaratively describe a 3D scene, which is exactly what UI should be doing. We're describing declaratively our UI with HTML. Why not the same for 3D scenes? I think that makes a lot of sense. In my case, I'm using audio, so I'm describing audio, which maybe doesn't make perfect sense, but still could be pretty useful as a concept. We're also seeing this implicit prompts pattern in a lot of Svelte libraries, particularly, mostly in a lot of SVG rendering libraries, particularly ones for data visualization. Svelte is in its documentation really sort of promotes this pattern. It's the only framework I've seen to really describe how you should use this. It's very useful. In their tutorial series, they actually have a maps visualization where they describe this exact pattern. The other frameworks, although they have the ability to do this, do not themselves encourage it. Occasionally, some React UI libraries might use it, which is why I brought up the tabs component, because this is a pattern I've seen before and used in React. The other ones might do the same. I don't have enough experience with them to know if those frameworks do that, but this is how you might do that specifically. Thank you so much. Sorry for the long video. Be well, think critically, adios.